Let's dive right into Python data structures. If you've ever found yourself wondering how software actually remembers and manages all that complex information you're constantly feeding it, you are in the exact right place for this explainer.
To really ground this abstract idea of memory allocation, I want you to picture a physical box. That box, that's your computer's memory space. The label written on the outside, let's say it says Amelia, that is your variable. And the 6 candies sitting inside the box represent your actual value. So when you run your code, Python is reading it line by line. If it suddenly needs info from line 1 while it's all the way down on line 5, it basically creates these labeled memory boxes, grabs the candy, or the data, when it needs it, and then discards it to free up space when it's totally done.
Here is our quick roadmap for today. First, the memory box. Second, categorizing data types. Third, organizing with data structures. Fourth, lists, the ordered sequence. Fifth, tuples, the immutable sequence. And finally, dictionaries, key value mapping. Okay, let's jump into section 1, the memory box. To really get a grip on data structures, we first have to look at how Python remembers the specific data you tell it to store. Think about trying to find a single item in a super messy room. You'd probably rely on labels on storage boxes, right? Well, Python does the exact same thing. It retrieves and works with data in memory by recalling variable names. It's simple, but man, is it powerful. You literally just create a label, drop some data inside, and whenever Python spots that label again in your code, it knows exactly what information you're talking about. Moving right along to section 2, categorizing data types. Building on that whole box metaphor, we obviously don't just throw everything into generic storage. Python uses specific data types to correctly process information. It's kind of like color-coding your boxes. For example, you've got integers for whole numbers, like tracking that you scored exactly 2 goals. You've got strings for text, like the name Amelia. Then you use floats for decimals, like a price tag of $7.99 or a time of 12.34 seconds. And finally, booleans. These are strictly true or false conditions, like checking if a store is currently open. Python absolutely has to know the type of data it's looking at so it knows what mathematical or logical operations it can actually perform. Which brings us to section 3, organizing with data structures. So we know how to store a single item now, right? A number, a word. But what happens when our data scales up massively? Imagine you have this giant, unorganized pile of sports gear. Soccer, tennis, basketball, all just thrown together in a heap. If someone asks you to quickly find the soccer boots, well, doing that efficiently is basically impossible. It's a total nightmare. And that is exactly the problem Python's data structures are built to solve. They organize vast amounts of items in the computer's memory to make retrieving and modifying them significantly faster. But before we look at the specific solutions, there's a crucial point we need to cover. You have to understand these 2 fundamental rules of Python. Some structures are mutable, which means they can be changed, updated, or modified long after you create them. Others are immutable, meaning they are strictly locked in place once they're made. No changes allowed. Understanding the difference between mutable and immutable is honestly half the battle when picking the right tool for the job. Let's look at some examples. Section 4, lists, the ordered sequence. Going back to that messy pile of sports gear, if you were smart, you'd put your soccer gear in the first box, tennis gear in the second, and basketball gear in the third. That way, you can immediately grab what you need just by knowing its sequential order. You just think, oh, soccer is in box 1. That is exactly how a Python list operates. It completely relies on order. It stores sequences of data, and you retrieve that data using its numerical position, which in Python terms is called an index. Now, because lists are highly flexible and mutable, you can constantly update them. You create them using square brackets, and from there, you get this massive toolkit. You can add elements with tools like append, insert, or extend. You can pull things right back out using remove, pop, or clear. You can even merge 2 completely different lists together just by using a simple plus operator. It really is the ultimate flexible sequence. Section 5, tuples, the immutable sequence. So, what happens if you have a sequence of data that you absolutely, under no circumstances, want accidentally changed? Well, that is where tuples come in. Remember how lists are mutable and let you use commands like extend or clear? Tuples are strictly locked down. They are immutable. If you try to use extend on a tuple, Python is just going to throw an error right back at you. They only support read-only methods like count to see how many times an item appears, or index to find its specific location. Section 6, dictionaries, key value mapping. Okay, let's look at a totally different way to organize your boxes, one that doesn't rely on numerical order at all. Instead of a sequence, a dictionary lets you slap a clear, readable label onto a box. This label is called a key, like a person's name, so you can instantly look up its value. Think of it exactly like a phone book. You don't look up a friend by remembering they're the 142nd person in the book, right? You look up their name to find their phone number. It's incredibly fast, and it relies entirely on association rather than order.
And this brings us to a really fantastic shortcut known as dictionary unpacking. If you prefix an existing dictionary with a double asterisk, Python essentially rips open that box and breaks it down into its individual key value pairs. This allows you to effortlessly pour those pairs into a brand new dictionary. It is such a fast, elegant shortcut for merging data.
You can even take this a step further and create nested dictionaries. This means you can place a smaller, detailed dictionary directly inside a larger one as a value for a specific key. Just imagine a dictionary for a company, right? And inside that, a dictionary for the marketing department. And inside that, a dictionary for individual employees. It allows you to build incredibly complex data structures that perfectly mirror real-world relationships. So let's tie it all together real quick. Lists are ordered, mutable sequences. Tuples are ordered, immutable sequences. And dictionaries are unordered, mutable mappings that use key-value pairs. Knowing exactly when to use which structure is honestly what separates an OK coder from a great programmer. Whether you need a highly flexible list, a completely secure tuple, or a lightning-fast dictionary, you now have the structural tools to handle some seriously complex coding challenges. So, with your digital boxes perfectly organized, which data structure are you going to use to optimize your next big project? Think about it, and happy coding.